The standard model is a really useful way of classifying particles. So in this topic, we'll start with very broad categories and work our way down to finer and finer categories for classifying different types of particles. So the broadest categories that we have for our particles are fermions and bosons. So fermions are particles which have a half-integer spin quantum number, and bosons are particles which have an integer spin quantum number. So remember that the spin quantum number is related to the intrinsic angular momentum of the particles. So you may be wondering, well, why do we really care? Why is the spin quantum number a good way to classify these particles? And it comes down to fermions with a half-integer spin obey the Pauli exclusion principle, which remember was discovered by Wolfgang Pauli, which says that only one particle can be in each state, whereas bosons do not obey the Pauli exclusion principle. So fermions are named after Enrico Fermi, who was an Italian physicist who discovered the statistical laws governing fermions and their behavior concurrently with the physicist Paul Dirac. So some examples of fermions that you'd be familiar with are electrons, neutrons, and protons. All these particles have spin 1/2 and they obey the Pauli exclusion principle. So as we've discussed, when we're putting electrons into atoms, we can only have one electron in each state because they obey the Pauli exclusion principle. So bosons are named after the Indian physicist Satyendranath Bose, who discovered the statistical laws governing their behavior at the same time Einstein did. So some examples of bosons that you would be familiar with are the photon, which has spin 1, and also the alpha particle, which has spin 0. So the alpha particle, as we've seen, is just a helium nucleus, so it consists of 2 protons and 2 neutrons. So bosons can actually be composite particles, particles which are made up from multiple fundamental particles. So what's so special about bosons is that they don't obey the Pauli exclusion principle, which means that we can have multiple bosons all in the same state. So you may have heard of the very interesting state of matter known as the BoseEinstein Condensate. And this is just when we have a whole lot of bosons all in exactly the same state, because it's allowed through them not obeying the Pauli exclusion principle. And this results in the Bose-Einstein condensate having some very special properties.